Good afternoon and welcome to Design Master Training. Today we are going to be looking at the options customization in Design Master Electrical for Revit. If you have any questions, you can put them in the chat box, and if you're watching a recording, you can call us at 866-516-9497 or email support@designmaster.biz. Let's get started taking a look at the options today. The first one is display neutral wire count separate from phase wire count, and this is purely a preference as to how you like to show those. The default is yes, so if we go to, say, a feeder which has a neutral, we list the phase wires and then the neutral wire separately. So if we change that option from yes to no, then we go over and take a look at, say, that feeder size. It collapses everything. You get 4 of those wires rather than the 2 separate callouts. Size your neutral separately. It'll still call it out separately because at that point you have different size wires. The next option is the conduit location. This is pure personal preference, whether the size of the conduit is at the front of the wire callout or at the end. So you flip that and it'll flip from the other side. Transformer voltage drop calculation. This one's actually kind of interesting. The question here is, when you're doing a voltage drop calculation, what happens when you go through a transformer? If you actually include the voltage drop through a transformer, you end up with pretty big voltage drops. So if we include the voltage drop through the transformer, obviously it includes the voltage drop through all the feeders and then through the transformer. And so you can see here, we've got like 0.35% voltage drop through MDP, and then we go through this transformer, and it's basically like a 2% voltage drop through that transformer. If you actually include that voltage drop, because there is a voltage drop through the transformer, if you include it, nothing actually works. You can't get your voltage drop to meet requirements. So you can say, okay, let's just ignore the transformer. Then the transformer, we just pretend we just pass the voltage drop straight through, and we go from that 2% to the 0.45. The final option is you can actually reset the voltage drop at the transformer. And that's where you would basically adjust the taps so that at the transformer, so that the voltage leaving the transformer is a little bit higher, so that it accounts for that voltage drop. So you basically reset to 0 at each point and then work from there. So those are the options we have for voltage drop. We have a choice for your feeder voltage drop. At what point do we warn you? Is it 3% or 2%? The NEC is 3% for feeder, 3% for branch, and then 5% total. California said we want it to be 2% for feeders, 5% for the total. Option for default for circuits, whether you include the room names, yes or no. You can override that at the circuit level. And then we have the calculation method for feeder and branch circuits, whether we're doing the calculation by default based upon right angles or a straight line distance, or based upon what Revit calculates, because that is an option if you're using circuit paths in 2018 and later. And then you can override that at each level, for at the circuit and feeder level as well. And then we actually have the angle of the building, if it's like 0 degrees to XY, or if it's 45 degrees off or whatever. If you have a couple buildings at different angles, hopefully you've got panels that feed those separate buildings, and then you can actually override this in the panel. For the branch circuits on this panel, we're going to do right angles, but it's at 45 degrees. So
okay, cool.
Downstream of this is going to use a 45-degree angle. Choice as to whether all shared parameter values are going to output as uppercase or not. And that's just a labeling preference. Then we have a feeder makeup where we add a specific length to the feeders. It's currently set to 10 feet. And you can set a different value there if you would like. And then for the voltage drop, we can either do the voltage drop based upon the actual load, or 80% of the panel capacity. So beginning of the project, you might set this to yes and just say, okay, what's my voltage drop, assuming I'm fully loading everything. And then later on, set it back to no once you have the actual loads on the panels. And finally, we have the power factor for the voltage drop. We can use the Revit power factor if that's defined properly. Or if that's not defined properly, we can just say, it's 0.85 everywhere. That's probably right. Thank you for watching our training on the options in Design Master Electrical for Revit. If you have questions, feel free to call us at 866-516-9497 or email support@designmaster.biz.